Tervetuloa tänne Esri Finlandin ja TomTomin järjestämään webinaari-aiheesta parempia päätöksiä liikennedatan ja POI-tietojen avulla myös reaaliaikaisesti. And now I'm going to switch to English. My name is Kai Ruponen. I'm working here as a Director of Business Enablement at Esri Finland. I'm sitting here with Maarten Clements from TomTom. Maarten, warmly welcome.
Thank you, Kai. And good afternoon, everyone on the call. Today I would like to show you how you can make smarter and more informed decisions using TomTom Data and Esri software. My name is Maarten Clements and I work as a product expert in TomTom Maps. Today I'm visiting the office of Esri here in Espoo with lovely weather, by the way. Thanks for that. But usually I'm based in Amsterdam, which is also the headquarters of TomTom. Here you can see the agenda for today. I will start with a brief overview of TomTom to show you who we are and where we come from. I will introduce the data products that we have and give a short demo of our traffic stats product. Finally, I will show some real examples from both commercial and government domains where people have really been able to use our data to make better decisions. So first, a short introduction into TomTom. Of course, we're a global company. We've been selling navigation devices, but also we've been making a map that spans the whole world, and to make a map you need a global workforce. So as you can see, we have local offices almost everywhere in the world. Even a small office here close to Helsinki, with our local map experts located there. This is a brief overview of our history. I just want to pick out a few points here. What you can see very important is that in 2008 we acquired TeleAtlas, which was one of the few global mapping companies at that time. And this has brought us a lot of knowledge and background into the geographical domain and a global workforce to build and maintain our maps. What you can also see is that we've been working for almost 10 years now on traffic data. So we acquired a small company in 2006, and since then we've significantly grown that business. So we've developed ourselves as experts in traffic, managing traffic and monitoring traffic across the globe. And in the more recent years, you can see that we have broadened also the consumer products, but also at the same time in the B2B market, started working on some very interesting strategic partnerships there. If you look at the TomTom business structure, most people know us from the left side, the consumer market, where we've been making navigation devices for more than 10 years, but recently also sports devices like watches and action cameras. But more and more we're also focused on the B2B market. We are growing in the automotive market, where you see more and more navigation software becoming integrated in the dashboard directly. It's not always recognizable as TomTom software, but under the hood it's often using our maps navigation software or traffic data. Next we have our telematics business. TomTom is currently the largest provider of telematics solutions in Europe. We have around 50,000 big customers, companies driving around with a fleet of cars. And we provide specific solutions like larger navigation devices and management software to dispatch jobs to the cars on the road. And last but not least, we have the unit where I'm working, TomTom Maps. The purpose of this domain is that we, as I said, all the content that you see in the TomTom devices, the maps and the traffic data, It's all owned and created by TomTom, and within TomTom Maps we have the purpose to make that content available for other companies or governments that can use that data in a wide variety of ways. And today I would like to show you some ways you can use the data and actual use cases, and how you can make smarter decisions based on that data. So if we talk about TomTom data, it's mostly about maps and traffic data. So what you can see here is that we have a global vector map with incremental updates, which means that more and more we're moving towards real-time, all-the-time updated maps. We're continuously monitoring the road and also using community input to directly be updated on changes on the road. And we send incremental updates if there is a problem with the map, so you can stay up to date all the time. On top of our map data, we provide a lot of real-time and historical layers of data. For example, traffic data that give you more insight in what is happening on this map in real time. And to dive a bit deeper into these two domains, here you can see on the left side a short overview of our mapping products. We of course have a global routable vector map, which means that you can load this data into, for example, an ArcGIS solution and plan a route or do all kinds of analysis on top of that. But next to the map we have a lot of different layers that provide additional intelligence on top of that map. For example, logistics information, which gives the restrictions of the trucks or hazardous goods that may or may not be delivered over a certain road. But also the heights of bridges and the width of the road, etc. We have POIs and geocoding information. So this is information about shops, retail locations, but also the exact house number locations of normal addresses to improve geocoding applications. In the bottom left you see our 2D and 3D display products, which really gives you a very detailed look into the 3D model of a city. On the right side we have our traffic products. The top two are real-time products, traffic incidents, which shows the current bottlenecks, the traffic jams, roadworks and accidents. And on the right you see TomTom traffic flow, which gives you the speeds on all the road segments updated every minute. I'll say a bit more about these in a minute. At the bottom you see our historical traffic products, speed profiles and traffic statistics. Speed profiles gives a profile of the real driven speed for each day of the week. And traffic statistics is a portal that gives you much more granular access to all our traffic data. And after this I'll show a demo of traffic statistics and what you can do with that. So as I said, we are a global map maker. This means that we are really driving around with these cars with LiDAR and cameras on top of the car. And we drive more than 3 million kilometers every year to keep up to date on what is happening on the roads. But we don't just drive random roads, so we use a smart way to detect which roads need to be monitored, and we keep in touch with the local communities, of course, to know what is happening and which constructions are currently taking place. Some more statistics you can see here. So we collect billions of probe traces every day, which is the real GPS data that comes from the cars, and we use this also to improve our maps. We have over 60 million points of interest, 250 million address points. In total, giving us about 50 million kilometers of roads in almost all of the world. So this is really big data, and we have all the internal structures to manage this data and to update this data currently monthly, but we're going to increase the update cycle to be able to really deliver incremental updates on a weekly or daily basis in the coming year. Also, if you look at our traffic data, we have a wide variety of sources that contribute to our traffic data in real time. So what you see on the bottom left here is, of course, our own personal portable navigation devices. If you have a connected device in the car, it means you're able to receive traffic data, but also if you give permission to do so, it will send back the location of your car in real time, of course anonymized, so that we can use it to improve the traffic information for all the other cars on the road. So basically you become part of the community that builds our traffic service. Next to the well-known navigation devices, more and more we see navigation device or navigation software being integrated in the car. And if you have a connected car, this also means that you become part of the community that helps to build our traffic system. So you can see some of the logos of the car makers we're working with here, but of course this is growing continuously, and we expect over the coming years that navigation software will move more and more into the car dashboard. So we are there to work with all these companies and to get this done. You can also see the commercial fleet vehicles. So a lot of cars, but also trucks and delivery vans are driving around with our traffic data, and they deliver data back to us real time as well. So this gives another look into the real-time traffic on the road, because this is again a different type of behavior. These people are often on the road almost 24/7, delivering goods or driving people as taxi companies do, giving us a better overview of what is happening on the road. You can also see navigation apps and mobile phones here. So we have our TomTom apps, but also we've partnered up with some of the bigger handset providers across the globe, and they also provide data back to us in real time. And in total, this whole landscape gives us a very good view of what is happening. Currently, real-time traffic in 50 countries, among that, of course, Finland. And we can say this kind of data is only growing. So the view that we have on the real-time traffic is getting better almost every day. And in total, this is currently generating really a huge amount of data. So we are collecting 742 million kilometers every day, which is more than 18,000 times around the world. So as you can imagine, we have quite a huge server park, machines running continuously to process this data, and within 1 or 2 minutes we receive all this data, we process it, and we send everything out again to all the cars on the road. If we take a closer look at Finland, here you can see a picture of the actual data. So this is not a map of Finland, but this is actually the raw data that we collect from the cars driving around. And you can see directly what is the benefit of this type of data, which is called floating car data. Is that it's not only capturing data on the main roads, but you can also see the smaller roads outside of the city. We're collecting data everywhere where there are cars with one of our partner solutions driving around. And in this way, we really get an overview of all the cities and all the roads in the country. So let's take a look at the products that we generate based on this data. The top two are the real-time traffic products that we have. On the left, traffic incidents, and on the right, traffic flow. Let's take a look at traffic incidents, TomTom traffic. What you have here is a real-time data feed that gives you every minute an update on the traffic jams and the roadworks. So this really contains the main bottlenecks, where is the current congestion, and which are the, if you're planning a route currently, which are the areas to avoid. This is also the data that is used if you have a TomTom navigation device. This is also the standard data that you see in your navigation device that tells you there's a traffic jam on your route. On top of this, we have some potential extras. We have a safety package that contains jam ahead warnings, which gives a warning message on the exact location where people are hitting the brakes. This is very interesting because those are also typically the most dangerous locations in the road. So also for road authorities, it's interesting to see where people hit the brakes most to avoid accidents on those locations. And another optional add-in is severe weather warnings. So we are now starting to merge weather information with our real-time traffic information, which can be, of course, very interesting in Finland as well. So we can see a snowstorm coming up. Then we can already start to warn people there is a traffic jam because there is snow in this area. And currently, we're also starting to use the road condition to merge that into our traffic product as well. At the bottom here, you can see that we also have some prediction features. So we also estimate the duration of a traffic jam into the future. So we try to predict when a traffic jam will be dissolved and whether it's growing or shrinking. So this can, of course, be very useful if you're planning a route and there's a traffic jam towards the end of the route, so that you know whether you should be worried about that or not. Our other real-time traffic product is called TomTom Traffic Flow. This gives not just the main congestion, but it really provides an update on each of the road segments every 60 seconds. So every minute you get an update on all the main and secondary roads. It's delivered with TMC, which is a standard method for referencing the information to the roads. But on top of that, we have another method called OpenLR, which really gives all the detailed information on all the secondary roads as well. We also provide predictive information here, so we can look into the future 45 minutes ahead of us. So we try to predict based on the current trend that we see, whether the congestion is growing or shrinking, and based on that, we send out an update that gives you a view into the future. So those were the real-time products. Now a quick look at the historical traffic products, which are more used for statistical analysis of data. First, speed profiles. This is actually a layer on our TomTom traffic or our TomTom map. So together with the map, you can receive the speed profiles product, which gives you for each day of the week an exact indication of what is the speed that is driven on that road at each moment of the week. So what you see on the right here is that we deliver 7 different profiles for a single road segment. for each day of the week. So for example, on a Monday morning at 8 o'clock, you can find out what is the real speed that people are driving here on this road at this time. And as you can imagine, this is often very different from the legal speed limit. So this is a much more reliable basis for logistics planning, for example, or just individual route planning. If you want to take it even a step further, we have a web portal where you can get access to all of our traffic data 24/7. So if you have a login to the portal, you can just go into the portal and request a sample of our traffic data for exactly the time period you want to analyze. So within the portal we have several products. The most interesting ones that I've highlighted here are custom travel times and custom area analysis, which allow you to analyze a certain road, a single road or a full area of roads. And what you can do is visualize the current traffic or the historical traffic conditions. For example, compare actual speeds versus speed limits, rush hours compared to free flow conditions. You can do before-after analysis by comparing last year to the current speeds, or even compare traffic density on different road segments. And now I would like to give you a very quick demo of how you could extract such data from our web portal and directly import this into ArcGIS to do a specific analysis. So if we go to the web portal, how it works is that you once you have a login, you can easily create a request by selecting a certain area. For example, if you want to analyze Helsinki, you can select the whole city of Helsinki. You can select the specific dates you want to analyze. So in this case, I've selected several months at the end of last year. And then you can also decide exactly which days you want to include in that analysis. So if you don't want to look at the Saturdays or the Sundays, you can easily switch that off. The third step is to analyze to indicate the time sets you want to analyze. So in this case, I have selected several hours during the night, which I will call the base set. I've selected 4 hours during the morning rush, and I've selected 4 hours during the evening rush hours. So once you have selected the area, the dates, and the time you want to analyze, the system will process the data and it will send you an email when it's done. And after that, it's simply clicking the download button to download the data in a shape format. Once you have the result file, you can simply load it into ArcMap, and it will directly give you the same area which you can see here with the full network of roads. So you don't even need an additional map to do an initial analysis. You can already start to highlight, for example, the main road classes, which you can see here, where I've indicated which are the main highways and the main secondary roads. If I click one of the road segments, you can see what information is exactly available there. So here we can see I've selected one of the road segments. It's a segment of 160 meters. Functional road class is an indication that we use in our map as well, which gives an indication of the size of the road, ranging from 0 to 8. This road has a speed limit of 70 kilometers per hour, and it gives you the name of the road, but it also gives you an identifier. So if you use the TomTom map as well, you can link it back to the map and do a more thorough analysis with this data on top of the map. So currently I'm only showing the network you get out of traffic stats, but of course we wanted to look at some traffic data here. which is delivered and as several database files exactly corresponding to the time sets we created. So we have a base set, an evening rush hour and the morning rush hours. So what we can do is couple this to our network and, for example, visualize the speeds that we have in the morning. So if we do that, it directly gives an indication of which roads are the main channels to reach the city center. Of course, the speeds are higher on the major roads. So we can select a road again, which gives you already a lot more information. So we have the basic network information. The street name is not correctly formatted, but I think that's just because I don't have a Finnish laptop. But below here we have now a lot more information, which is giving a really detailed look at the traffic conditions in the time period that we have selected. Everything starting here with BS, that's the base set, so that's the data set we selected in the middle of the night. And then I also coupled the morning speeds, which are below here. So one of the things you can see here is, for example, the average travel time during the morning on this road segment. The average speed is 100 kilometers per hour. So people are driving quite quickly on this road. We see also a standard deviation and also the number of measurements that we have on this road. And below that we have even more detailed information. These are all the percentiles of speed. So you can actually know what was the speed of the 5% of the 5% fastest cars that were driving on this road in this selected time period. So one of the more interesting things we can do, of course, is not just look at the speeds, but actually compare the speeds in the morning to the midnight speeds. And this gives you directly an indication of the main bottlenecks that we have in the city. So if we zoom into, let's zoom into a specific area. And what you can see now is that the green roads are the roads where people drive more or less the same speed during the morning rush and the midnight. And the red road segments are the main segments where you can really see the congestion forming. So for example, on this road segment just off the highway, we can see that the speed during the midnight is around 50 kilometers per hour. It actually has a speed limit of 60 kilometers per hour. And if we look at the morning, we see that the average speed of everyone here is only 31 kilometers per hour. So in this way, you can see that you can do a very detailed analysis of what is happening on this road at a specific selected time of the day. We can do even more thorough analysis by, for example, looking at the speed limits. So as I said, we have the speed limits in the system as well. So unfortunately, we cannot allow law enforcement based on this data, but of course you can analyze the effect of a change in speed limits and see how people are actually behaving based on the speed limit signs. So in this case, I have made a comparison of the average speed in the afternoon, normalized by the speed limit on this road, and I've colored the streets accordingly. So you can see that the red roads are where people are often driving a bit faster than the speed limit. So here we have a speed limit of 60, while in the in the afternoon, I think. Let's see. The average speed is around 71 kilometers per hour. So this kind of analysis you can do based on this data. What you're not allowed to do is put a police car there, but you can at least understand how the traffic is behaving based on this data. So let's go back and look at some actual use cases of how different companies and municipalities have used our data across the globe. So if we look at municipalities, we know there are a lot of questions that we might be able to help you with. So for example, infrastructure. How can we analyze the infrastructure and how can we improve it? So the standard products that we could recommend for that is, of course, the standard base map and the speed profiles and traffic stats to see how fast people are driving and to analyze the main congestion on the road. First example I want to show here is in the north of the Netherlands. This is an area where it's both densely populated, but there are at the same time still some green areas that, of course, the government wants to preserve. So they've done a very detailed analysis here to see where is the main congestion and to also get a model of greenhouse emission. So to see where should we make our improvements to both help the traffic but also help the nature in this area. What they've done here is they used our traffic stats portal to extract a custom selection of the roads, and they analyzed the exact speeds of the cars and the volumes of the cars at each moment of the week. And this has helped them to build a model and to improve, to make specific changes to the road network and improve the traffic flow over this whole area. Another example here from Germany. In this case, they already knew pretty well where the main congestion was located. So there were specific corridors, specific roads where they wanted to. They knew they were heavily congested, but they wanted to get a bit more detail of which road segments were causing that congestion and to analyze deeper what they could do about it. So in this case, they used the custom travel times, which allows you to analyze a selected road to get a very detailed view on this specific road to see how to improve the traffic flow on this road. And a third example in this area is from the Basque area, the north of Spain, where you can see that they have been using our data for a long time, and they really analyze the speeds on different days to see what is happening on this road. And by doing this for a longer time period, they have by now a very detailed look into what is happening on the roads, and they continuously use this kind of data to make improvements to the road network. So if we talk about traffic management, we also have to look more into the real-time traffic products that we have, which are traffic incidents and traffic flow. And some of the traffic control rooms across Europe are really using this data on a daily basis to look at the situation on the road. So currently we're looking at Berlin, who have used our data for more than 5 years already to get a very detailed look at what is currently happening on the roads. How does that correspond to the roadworks that are going on? Where do we see the main congestion? And how can we make real-time decisions to improve the traffic condition on the road? We have helped them to set this up together with an integrator, Siemens. So we build a complete solution for them to allow them to not just look at our data, but really merge it with the data sources they already had in their traffic control room. And also we have an example again from the Basque region. So as I said before, they've used our historical data for a long time, and they also are able to combine that data with our real-time data. So they get a view on the real-time situation in the whole area, and at the same time they can look back at the situation on the road on, for example, the same day last week or last year. So they can directly see whether the current situation is an abnormal situation or whether this is a normal behavior on a Monday morning, for example. We know municipalities have a lot more challenges. For example, public transport management, emergency services, waste management, and utility management. And often these come down to logistical problems. So these often involve bigger trucks or buses that have to navigate through busy cities, and we can all group this under our logistics domain. So what we generally offer in this domain is our standard map, but on top of that we have a logistics layer that gives you a bit more insight in what you can do with trucks, where you can drive with trucks, and plan routes that are specifically suitable for trucks. On top of that, we of course can again provide our real-time and historical traffic data to make the best decisions at a specific time of day. If you combine all this data in ArcGIS, of course you can do a very thorough analysis. For example, if you want to plan a route through 8 different locations in the city, you can see that by using the network analyst, you can find the optimal route at a specific time of day. And because you have TomTom data in it, you know which is the most effective time to drive a specific route. So one of the organizations doing this is a public transport in Italy called ATAC. They use our data to really plan the schedule of the buses in the city, to know what is the most effective route to drive the bus. A completely different example in Catalonia of the fire department, and they actually use it now also for other emergency services. What you want to know as an emergency service is what is the reach of my fire truck, for example, from a specific location. So if there is a fire somewhere in this area, can I reach it within 10 minutes, or do I take half an hour to get there? And you can of course use this kind of data to do an extensive analysis to see what is the reach from each location, and am I really covering the entire region, or should I put another site for fire trucks somewhere in the region that I'm currently not covering. And as I said before, we also can help out with waste management. So there are a lot of trucks driving around with hazardous materials, and you want to plan a route that doesn't go through the most densely populated areas there. So we do this kind of projects as well. In this example, in Italy with the Ministry of Environment, they used our data to really optimize the routes that the garbage trucks are driving, not only garbage but also other trucks with hazardous materials. And they used our multinet map and the logistics data on top of that to find the optimal routes. And this is a short overview of what you can do within municipalities. Now a few more insights into a completely different domain of retail. So the few topics I want to discuss are out-of-home advertising, site selection, and I will not touch on logistics today because it's quite similar to what I just showed for communities. So first of all, out-of-home advertising. You can imagine that, for example, you're owning a set of billboards and you want to make most effective use of these billboards. So some of the questions you run into is, if I put an advertisement on this billboard, how many people am I reaching? Where do they come from? Where do they go? And how fast are these people driving on this road? So the data we use for that is of course our map, and you can use our traffic statistics to get a view on where do people come from and how fast are they driving. One of the companies we're working with at the moment is Interbest. They own a lot of the highway billboards, so they want to know for this billboard next to this road here, how many people are passing this billboard at each moment of the week, so they can make a very detailed analysis of these people passing this message, and they also know how fast these people are driving, so they can exactly compute what is the time that people get to view the message displayed on this sign. Another company currently using this kind of data is Asterop in France. This is a company specialized in demographic analysis, so they do a lot of measurement of where people drive and how they commute. And they use our data to get all sorts of insights into where people go and how fast they drive, where they come from. Also for example, for billboard advertising, or for example to analyze the optimal retail sites for specific companies. One of the other options that we have here is site selection. So imagine that you're a gas company, for example, and you want to know, do I reach more customers than my competition? Am I positioned at the best location in the city center? Or should I put another gas station somewhere at a very strategic location? And you can use our data to do this. Of course, you start again with the global vector map, but this time you can, for example, use our POIs to get an insight into the locations of your competition. And you can again use our traffic data to see how reachable is my site during specific moments of the week. One second. So here you can see our speed profile data loaded into ArcMap, and on top here you can see the time is currently 4 o'clock, and if I start playing that time over the morning, you can see that during the morning the congestion starts to form in Antwerp here, and you can see more and more road segments becoming yellow and red. Which gives you a very detailed look into what is the best time to start driving here. And if you use Network Analyst in ArcMap, this gives you a very detailed insight. For example, if you have a site located at the blue spot here, it gives you a very detailed insight in what is the reach of this site. So how much time do people need at each moment of the week to reach my gas station, for example, and how effective is this? So you can see that at 8 o'clock your reach is much smaller than, for example, during the midnight. So this type of analysis can really help you to make decisions about your business. For example, a gas company in Italy, Eni, they used our data to do exactly this kind of analysis. So you see here that they plotted multiple filling stations on the map, and they managed to analyze how effective is my location compared to the competition. And we've done a similar project in Germany with Jet. They actually used traffic stats as well, custom probe count, to also not only see what is the reach of the traffic of the gas station, but to also see which are the roads where most people drive and which percentage of cars take a certain exit, and would it be useful to put a gas station near this exit, or should we put it near to the next exit? And that concludes my my overview of our data and how to use our data to make smarter decisions.
Thank you, Maarten. It was very fascinating presentation about data and the data you are collecting. So it was perfect. So